So we've had a presentation about running a root name server on the loopback interface. Now we have a similar draft in some ways because there is we're talking about running root name servers in more places, and the loopback is one of the places. These drafts do not really conflict or compete with each other. They could both progress in the IETF and become standards, and it's really just saying, if you want to do this, here's how, for two different values of this. So I'll get to some of the differences, but first let me just roll through the presentation itself. I did send the updated text of the next version of the draft to all of you last night. I realized that did not give most of you time to read it, but these slides are a short summary for those of you who have not read it. So there is unfortunate centralization in the internet, and by that I mean that there are island countries who have a small enough number of wet links that they have all been down at the same time. New Zealand, for example, had that problem about 15 years ago, and discovered that it would really be in their best interest if some of the root name servers could have addresses that would answer on New Zealand rather than not being able to find the .nz servers because there's a connectivity problem between New Zealand and the rest of the world. Fiji's had the problem. Certainly there are parts of the world that don't have reliable electric power, and they can't necessarily reach their own servers and services because of something else that's broken somewhere else. And I regard that as kind of the opposite of the intended effect of the internet, right? It's great that we have this global network, but sometimes what you really want is a good local network. And those of you who are old enough to remember the Apple Talk days would remember that you just sort of plugged it in and it worked, and you could reach everything that was local to you. And granted, that was a tiny network, and you couldn't do anything like the internet with that type of technology, but it showed a different approach. So if you think about DNS and perspective, if you are a content provider, you're running a TLD server, root name server, any kind of an authority server, you don't have a problem because you're able to spend as much money as you think is appropriate and get a direct payback in terms of the reachability of your content. So that means it encourages and to some extent guides your investment. And so if massive over-provisioning is part of your business plan, you can get that for yourself. And so that means you have extremely high availability among the clients you know about and care about, which is to say most of them. And you can even go to outsourced providers like CDNs, who will have what I sometimes have called stupid DNS tricks to give a different answer based on where they think the client is coming from so that they can somehow speed up web access. And these are all things that are options. And so, again, there is not unfortunate centralization from the point of view of a DNS content provider that I know of. From a DNS content consumer's perspective, that is less so. In fact, that's not so at all. You cannot spend money to improve other people's networks. There's no linkage in the money graph for that. So to the extent that you want to be able to reach the internet and reach your own net, you want to reach other people's networks, you're depending on them to make investments. All you can really do is improve your connection to, quote, the internet, unquote, and hope that the rest of the internet does the same. But that means there's no guidance to your investment in terms of your ability to reach other people's content. And that gives you some external dependencies that are business risks. And I mentioned that it's possible to not be able to reach a server that is local to you, perhaps in the same building, sometimes because you can't get the data you need from the rest of the internet to tell you that the stuff you want is on the same network as you. And there's also a surveillance problem. And I want to say that I've been considered a conspiracy theorist by some for a lot of years. I've been worried about surveillance for a long time before anybody had heard Edward Snowden's disclosures. I really don't like the idea that people can snoop on each other, and so this has been an issue in my life for quite a long time. But the fact that your queries, the queries that come out of your server, end up sort of going all over the internet into other servers across other links that you don't know who's monitoring them is another business risk, because that means your activities are not private. You don't have as much privacy as you should have. So the internet is a network of networks, but those networks are also networks of networks of networks all the way down. It's a recursive definition, in other words. So the constituent networks, like, for example, this hotel or this wireless or my house or your business, need, and in my opinion they need, and in their own description they want, autonomy. They don't want to depend on the rest of the world for everything that they do. So that would include locality of administration and control. So DNS does one thing very well for authority providers, which is to let you do a local delegation without any central permission. So that's been huge, and I believe that was PVM's intent. But when you're talking about sort of what you need to do for your network as a content consumer, again, you can't necessarily cause other people to invest in your network's reachability or your ability to reach their content. All you can really do is pose a force in the market and hope that the invisible hand of that market answers you somehow. And autonomy would also include the locality of this investment performance feedback loop that I was talking about, where you can spend money locally in order to change your circumstances. So it's an encouragement and a guidance for investment. That's not happening for content consumption. And this business of privacy is, I think, the most important and compelling argument right now, which is that a lot of what you do is visible to other people. And this is kind of the opposite of autonomy in all three of those cases. Now, David Boggs was one of my mentors at the DEC Western Research Lab, and he had all kinds of pithy sayings, and this was one of them, where he said that the definition of distributed computing was that you couldn't get work done because of a computer you never heard of in a room you didn't have a key to was broken. Now, he was one of the inventors of the Ethernet, so you'd think that he would have been a little bit more favorable to it, but it turns out there are some bad side effects to all this distribution that we do, which is that there tends to be a DHCP server or a file server or something somewhere that you are dependent on. And, you know, we moved as an industry in the direction of thin computing, diskless desktop workstations and so forth, and we've generally moved back. I know that Chrome and some other tablet-style operating systems are once again encouraging what's called the cloud now that it's come back. Needed a new name. But I at least can do anything I want to do on my laptop. It's got an operating system, it's got storage, it's got applications. If I can't get a connection, I can still get work done. And I like that. People keep telling me how great it would be if I would switch to Chrome, and I keep saying, yeah, but I want to be able to answer email while I'm on an airplane, disconnected, kind of thing. And that, again, is the sense of Boggs's observation, which is that you can easily distribute too much. So in DNS, this internal content is reachable through an NS chain, delegation chain. So the root points at the TLDs point at the second level domains, and so forth. And what that means is that to find a TLD or SLD that is very close to you, you will need to make a transaction with a root name server that might be very far from you. Even though if you knew the address, you could reach it directly. The fact is you don't know the address, and you don't even know that it is a name server unless you can ask the root servers, who will give you that NS record. And the same is largely true if you're an SLD. I myself am under .com, so I depend on VeriSign being up. Unfortunately, they always are. But the connection between me and them is sometimes not as reliable as it could be. And I think we might want to discuss, maybe not today, but if we have time tomorrow, we might want to discuss ways to have the servers that are close to you become knowable by you without having to seek external help to get them. Certainly in PVM's original environment, there was a name server that was the recursive server, and it was the authority server for the zones he cared about. And so he didn't have this problem. The internet is a lot bigger now than it was then, so we tend to have that problem. But you also need your registrar to maintain your NS records and your DS records. And while the registrar and registry system are pretty good at doing that, A month has not gone by in 2014 that I haven't heard of somebody having a registrar compromise where their keys are stolen and their NS records are changed to point at somebody other than them. And a week has not gone by in 2014 that I haven't heard of somebody doing a key roll on their zone and then not remembering to update their DS records or not being able to update their DS records fast enough. So it's an incredibly fragile system. And that term fragility came up in the earlier talk, and so I just want to say it's not necessarily, you don't have to necessarily follow the Hoffman-Kumari proposal in order to have a fragile system. It may be that there's fragility there, but there's fragility if we do nothing too. And this is the near opposite of autonomous. Same thing with surveillance. The DNS transaction logs have been a huge boon to the security industry, because if you can see the transactions that are going either between recursive servers and authority servers, or if you don't mind the PII aspects of it, seeing the transactions between the stub servers and the recursive servers, then you can learn a great deal about how the internet is connected without making any queries of your own. You can sort of just study this passively and build your own data structures that somehow model the topology of the internet. But this is also very useful for market research. To the best of my knowledge, the VeriSign team does not data mine the COM query stream looking for NX domains so that they can then figure out what domain to register, because obviously if it's getting a lot of NX domains, it must be popular. But I trust the VeriSign team a lot more than I would necessarily trust the other 245 TLD operators out there. So I have a feeling that there is some data mining going on. And if not by the registry operators, then perhaps by people that are serving their content. Maybe if you're outsourcing your secondary service, or if you're worried about security agencies simply tapping your wire. There's a big move afoot to do DNS privacy to make these wires less tappable, but we're years away from having a solution that would then have a long tail. So that by itself is not the solution I would be looking for. So this has big implications on outsourced recursive DNS. If you are sending your stub queries to Google or to OpenDNS, then you should read their privacy statement and make sure that you know exactly what they are allowed to do with your query stream. And you know, I feel certain that both companies are doing what their privacy statement says, but I think I'm even more certain that most people don't read the privacy statement and realize what that statement says. But if you are sending your stub queries, that means you're sending personally identifiable information about exactly which user at what time wanted what thing. And that is just a gigantic gold mine for both commercial and sort of intelligence service surveillance. Now, if you're not doing that, if you're not outsourcing, you have your own recursive servers, you're still leaking information. So if you need to be told that you have a name server for your own domain name inside your own hut, then you're likely going to go outside of your network to get that information, at which point the full query name that you started with is going to be visible to people not part of your company or your family or whatever, and their interests may not be aligned with yours. And especially information about lookups for external names not pointing back at you. The fact is, your recursive server, although it's in-house, still has to go upstream whenever it has a cache miss, and that data stream is extremely useful to people who, again, whose interests might not be aligned with yours. So again, this is the near opposite of autonomous. So, this proposal concerns hierarchical Anycast DNS service. And here I'm trying to give some names to the different layers of that internet, which is a network of networks, and so forth all the way down, which is that every host, every connected host, every laptop, every smartphone, every desktop, every connected host has a loopback interface. This is a network on which processes running on the same computer can exchange data with each other. And this is kind of a wonderful network in one sense because it does not depend on anything. If you're not connected to the wireless, you're not connected to anything, you're still connected to your own little loopback interface. It's extremely reliable in that sense. And in the Kumari and Hoffman proposal, they're recommending putting a name server there. I also recommend the possibility of putting a name server there, but I'm going to mention the possibility of having a name server on your LAN, which tends to be one step up from your loopback. On your campus or your residence or whatever it is, something larger than your LAN, some collection of LANs, possibly a corporate-wide network. Then you have an internet service provider network, which tends to be an access-style network that is selling you what connection you need, but then they have a network service provider that they buy connectivity to reach the rest of the internet on your behalf. Those NSPs tend to be interconnected either directly to each other or through internet exchange points such as PAX or Equinix. And then eventually you get to this cloudy thing that we call the core. And nobody knows exactly what that means, except that it is it's the default free zone. It's where that is the last resort. If you were not able to find what you were looking for on your pathway from the loopback going up through these other layers, you're going to go to the core where you either reach what it was or be told authoritatively that it can't be found, or it times out because it's unreliable. But this is essentially the way I'm viewing the layer of networks that makes up the internet for any given user. Now, every one of those layers has IP routing functionality. Even your little smartphone has the ability to answer the simple question, is this IP address something that is on my own loopback network? Is it something that I can just deliver to another process on my computer? And that's a routing decision. So your smartphone is an IP router in that sense. And generally, what you want is not to be found on your smartphone or your desktop, laptop, whatever it is, and it will have to go further up. And if it's something that's far from you, it's going to have to go all the way to the core and then come out a very similar looking chain going down toward somebody else's server on the far end. But that is routing. Technically speaking, that is routing. And anytime you're doing routing, you have an opportunity to add an Anycast DNS service. We're going to hear later in the day how this works for AS112. But it turns out that some root server operators have been doing that sort of Anycast for a long time. So we have FRoot well represented in the room. And I can tell you that at FRoot, where I used to work, there is a difference between global nodes and local nodes. And that difference really has to do with how far they attempt to advertise their service. So the local nodes tend to be as regional as possible, and then the global nodes say, I will take traffic from anybody. And yeah, there's a little bit of work that goes into it, because sometimes something you thought was local gets turned by someone else into something global, and then there's tickets get opened and phones ring and so forth. But generally, this type of hierarchical Anycast is already working in the root name server system and has been for 10 years or more. And it's not just FRoot. And as I mentioned, AS112 uses something like this. These are servers for the PTR record repositories for network 10, 192, 168, and so forth. So these are the shared address ranges. And there really can be no global authoritative PTR record for a shared address. It's something that if you're using them at all, if you're using this type of address at all, you should be overriding the queries that go toward those zones so that you can answer authoritatively for your own internal use of net 10 and net 192, 168, and so forth. A lot of people don't, and so their queries were headed up to the root name servers and getting answered with NX domain. I think I mentioned earlier, if not, let me mention now that 98% of the queries that are sent to the root name servers, which let's say there's somewhere between 100 and 200,000 of them per second, that means that between 90 and 190,000 of those are junk. And a lot of that junk used to be in-adder traffic for network 10 and so forth. So AS112 came up with the idea, and we're going to get a longer presentation on this from Paul Hoffman later, that if you could just delegate these zones to some server somewhere that could give you an NX domain so that you could get on with your work. It's because it's likely that you're in some kind of a work loop, or this is an inner loop activity to go find out what is the name that goes with this IP address. You want that work to continue as soon as possible, so the latency of your negative answer matters to the performance of applications all over the network. And it's also great to keep this traffic out of the core, out of the routes, and so forth. So we've been doing hierarchical anycast in the AS112 system, again, for more than 10 years. So this proposal is to do something similar for the root name servers. Hello. Now, I want to make sure everybody is aware of what this proposal is not. I am not proposing adding more root server operators. I don't want more letters. We have 13. 13 is working. I've recently gone on record recommending that we try and find out what is a better number, because maybe the 13, although it's working, is not the ideal number, but this proposal is not about that. I am not trying to put more pins in the map. This is not about allowing local names. I believe very strongly in the slogan which ICANN has adopted, which is one world, one internet, but I've amended it. One world, one internet, one namespace. It's very important to the success of, and the continued success, continued growth of the internet, that if you're looking up a name, no matter where you are, no matter what ISP you're in, no matter what country you're in, that name works the same way it would work anywhere else. And that means it can't be that it only works if you're in a certain airport or in a certain company or whatever. And I realize there are some exceptions for things like .local, but those are understood exceptions, right? The universality of the naming system is near and dear to me, as I hope it is to you. I'm not trying to dilute IANA's responsibilities at all. I think that IANA has done a fine job. All of the contractors who have had that role, all of the employees who've had that role inside those contractors have done a fine job. In fact, I'm asking them to take on more work, not less work. So this is not me attempting to take anything away from people who have something now. And similarly, I'm not trying to dilute the impact and the role of the existing 13 root server operators for two reasons, really. One, there would be a huge long tail on this, and we would never see full conversion. So the 13 root server operators, as they are today, will always have an important share of the internet traffic load, no matter how well adopted this proposal becomes. But furthermore, there's a role for them in this proposal. Right? They have all these Anycast nodes all over the place. It's fairly trivial for them to add one more service address in each one of their locations, and thus continue serving as the global server of last resort, as they do today. So why now? This has been proposed over the years, and I and some others have loudly said, no, we can't do that. And I think really the reason I have opposed it until now is because the temptation to add top-level domains that only work in your ISP or your country or your airport or whatever it is too high. It's extreme temptation. It is possibly as strong as the strongest drug addiction you could imagine, is the desire to control your own namespace. And if we had put this out there without DNSSEC, so that the people who were downstream of you would suddenly start getting whatever namespace you thought they should have and could not tell that you were spoofing them, then that would have undone what I said was so important to me, which is one world, one internet, one namespace. So it is the advent of DNSSEC that causes this to finally be a proposal I'm willing to make instead of standing against it as I have done in the past. Now, what this means is that your recursive DNS operators have to be able to detect non-IANA data, which DNSSEC allows them to do. But we couldn't do this until the root zone was signed, and DNSSEC was fairly widespread and available in most of the name server software that people might want to run. So currently, and this is very similar to the previous presentation where it was said, you know, people are already doing this. And that's true here too. People already do kind of what I'm describing. Their workarounds are kind of ugly though. You can grab the IANA root zone from a cron job or whatever, periodic job that will pull over that zone, and you can strip off the IANA's DNSSEC signatures, remove the IANA's NS records from the apex of the zone, add your own NS records, sign it with your own key, and then distribute that internally. And to the extent that you can get cooperation between the operator who does all of that work and all of the recursive servers who then have to have a different hints file, this takes you completely off the map. This removes you from the IANA root system. Although you're still a subscriber to the IANA namespace, you're not a subscriber to the root zone through which IANA currently delivers that namespace. This is happening right now. I know people who do this and are, paid perfectly good paychecks to do this for a living. You can also pirate the addresses of all the 13 existing roots. And this is happening. There are parts of the world where if you try and reach F root, you're going to get an answer, or any root, you're going to get an answer from something very close to you. And you can even use the NSID mechanisms that I think Suzanne was responsible for writing, where you can ask that server, what is your identity? What is your host name? Tell me something about yourself, and it'll be something you never heard of. But this is people who have what they think of as sensitive, high-security networks. They need high availability for this service, and they don't really care about the allocation of that address to somebody else. What they treat it as is a utility, and they're simply going to answer this global utility address through the same type of anycast mechanism that I'm describing here. So given that these are happening, what I would like to do is give them a way to do it right. And this again echoes the remarks made by Paul Hoffman earlier, which is actually by Terry Manderson, which is, given that people are going to do this anyway, couldn't we somehow make this, give them a way to do it safely? Now, in principle, a nation state could do either of these also. And I've been amazed that no one has, because there's a lot of concern around the world about the supposed U.S. government dominance of internet content and top-level domains and ICANN and so forth. I don't see that dominance myself. I see the U.S. as kind of an equal partner, a little bit disorganized and so forth. So I don't worry about them as much as the rest of the world seems to. But the rest of the world could be doing what I'm describing right now. And again, I would like to give the rest of the world, nation states, companies, ISPs, individual laptop owners, I'd like to give everybody a way to do this safely. So here's the actual proposal. I want IANA to publish 2 root zones instead of 1. And this root zone is a series. It's not a static element that you make once and then walk away from it, because every day somebody somewhere has a TLD where they need to add an NS record or renumber some of their glue or whatever. And then we've got the GTLD problem where we keep adding new generic top-level domains as they complete the process. So this is it's a constantly edited stream. And what I'm asking now is that we create 2 outputs along that stream, not 1. So the current one will continue as before, no change. But I'm asking that IANA also create a second one, having a different set of NS records at the apex with different IP addresses than are currently present. So it would not be any of the existing 13 names or 25 addresses that you get from the current zone. And I would like them to sign it with the same root zone signing key that they use today, and that would mean that it would be subject to the same periodic meetings in bunkers at various parts of the world where they pull out the key signing key and make a new zone signing key and so forth. I mean that key. It's the one people are using to validate IANA's content. I want it to be usable to validate this content. So I'm proposing at the moment that we give each of these 2 new unowned anycast root name server addresses 1 IPv4 address, 1 IPv6 address. I'm proposing that network operators who want to provide this service, first they have to decide whether they're going to provide it locally, for example, on your loopback interface to yourself, or regionally, perhaps within an ISP or within a company or within a nation, or globally. And I think that there's a good chance that at least a handful of the existing root server operators would say, hey, we love this work. We're happy to serve it at an additional address over and above the one we've used historically. But I don't ever want anybody to serve both addresses. And the reason is things go wrong. And I'd like it to be that if something is wrong with one of the 2 IP addresses that you think of as your root name server, that the other one still has some hope of answering you. So I would like, IANA will have to publish a second hints file, but the hints file is a simple text animal. And then interested recursive server operators can switch to this new root zone, which is really the same namespace again, but it's just a different metadata at the top of it. They can switch to this by simply switching their hints file. And this is completely cooperative. In other words, it's changed to the system by adding new capabilities and adding some new responsibilities for IANA. But anybody who doesn't want to run one of these servers doesn't have to, and anybody who wants to continue using the existing 13 root name servers can continue doing that. So no one is required to do anything in order to make this real. So there are some positive and negative impacts that I can predict out of all of this. And the thing I love the most is what I listed first. Anybody who wants to be a root server operator can be. So I could run root name service on this smartphone if I chose. And any recursive DNS operator who wants to participate can participate. And if a group of those people, the network operators and the recursive server operators, get together and decide they're going to do this in a coherent, cooperative fashion, then they will get root name service that I think will be better than what they get now, because no matter how well anycast we are, we only have 300 servers, and I don't imagine that we could reach the point where we had 3 million or 10 million, whereas this mechanism could do that. And it would put all of their dependencies inside their control, where their investment could impact their experience, which is not true today. And existing root server operators, again, if they chose to continue global service for these addresses, they would just be the root servers of last resort, which is kind of like how things are now. Other expected positive impacts, before we get into the negative ones, this might make people more aware of DNSSEC and encourage them to turn it on. And I think that's also true of the Hoffman and Komari proposal. Right now, a lot of people have heard of DNSSEC, but they don't think it affects them. I think they're wrong, and this is one way of getting the word out. This should discourage some of the piracy that we're seeing of the existing 13 root server addresses, or 25 addresses for 13 names, because now there is a standard way to do this. There's no reason to intercept traffic to somebody else's IP addresses anymore. You can just do it with something that IANA is publishing and signing for you. And it will, I think, avoid temptation of editing the root zone, right? If you can get this type of locality and this type of control for yourself without having to strip off IANA's signatures and edit its zone, then you're not necessarily going to see that there is also an opportunity to edit the namespace and add a bunch of local names, or perhaps delete. This is even a greater concern. There are many places in the world that like to pretend that certain other countries don't exist. Right now, there's great temptation, if you're doing the editing anyway, to go remove certain countries from your namespace so that they just don't work for you. And again, I think we can remove that temptation if we provide a signed zone that lets people do what is the fundamental motivation for doing what they're doing. Now, there are some negative things, and several of you have told me these loudly. I hope I have recorded all of them, but we have time for discussion, and we'll discover which things I forgot to list, or new things, new reasons that this is a bad idea. But what I've determined, I agree with these, in other words, is that if you move from hundreds of moving parts to millions of moving parts, you're going to increase your aggregate error rate, because that error rate follows complexity and number of moving parts. And I don't know what to do about that, because we have a certain risk profile now. So this is a different risk profile. I can't tell you if it's enormously greater or smaller, but it's different. It also means, and this again refers to DIDL, Day in the Life, which is a DNS OARC activity started by Casey Claffey back when that was an NSF grant. Not all forms of surveillance are bad, right? I myself don't mind having my queries in the DITL collection because it is only used for academic research and so forth, and it doesn't really have privacy implications, and I think people ought not worry about it. But I know that there are people who do, and so this is a controversial element, whether there is such a thing as good surveillance, where it's for academic purposes, or whether any time that somebody can see what somebody else is doing, it's a bad deal. Right now, we're kind of spinning in reaction to the Edward Snowden disclosures, and so it's very easy for most people to convince themselves and to convince those in the room with them that any kind of surveillance is bad, but that may be overreaction. And this certainly would give DITL less data to collect. Now, it may be, if this is a supported activity of IANA and there's an RFC that describes it, which we can't decide here, of course, but if it went through the normal IETF process and became an RFC, then it may be that we could at least have some outreach in that RFC saying, by the way, if you're going to do this, you should join the following mailing list so that you can, or go to this following website, something like that, so that you can participate in periodic data collection. The people who are doing this right now don't have that option. But if we made this a standard feature, then we would have some hope that DITL might be able to include some data from some of those people. Now, Notify is interesting for me personally. It was my first RFC, and it is the only RFC published in the year of its number. So it's cool. It's junk. The protocol is terrible, but it's interesting for those two reasons. But it relies on the master server, in this case the root zone publication server operated by VeriSign, which is actually I think 3 or 4 of them now, knowing the IP addresses of the root zone secondary servers and being able to send a notify packet to each one of them every time the zone is revised. That capability would be very hard to establish if we truly had millions or tens of millions of recursive name servers. I'm not saying it can't be done. I'm leaving it open that IANA might be willing to run a registry where people could say, hey, whenever it changes, could you please send a notify packet? But I think worst case, we end up going off the notify protocol and having to do use the AXFR timer to do a periodic serial number probe. And there are 2 timers for that, and they haven't been used for a long time because all the root servers today use notify. But with some careful tuning, I think that could probably work out. But the one thing that will not let us do is correct a mistake. Now, it's been more than 10 years since there was a mistake in the root zone that required an out-of-sequence publication or revision of the root zone. But I will say that when that had to happen, all the root servers were in sync except one that was broken within 5 minutes of correcting the defect. And that capability would disappear under this design. It would also disappear in the Kumari-Hoffman design. Now, I mentioned that for diversity, I'm recommending 2 servers, and I'm saying that no one operator should operate or should answer both of the server addresses from the same infrastructure. And that's just a little bit of protection against configuration errors. There will be, we know, the law of large numbers tells us there will be configuration errors. It would be good if we could limit the impact of those errors. On the other hand, 2 might not be enough, because it's very easy if you only have 2 servers for both of them to be broken at once. So we might decide that 3 or 4 was a better number. But above 3 or 4, this thing starts to look suspiciously like the current system. And I'm not sure that's the right thing either. So that's it. I apologize for the strange way that the drafts have been released, right? The draft that is in the repository, the Internet Draft Repository, is a little bit hard to understand because I didn't help enough with it. And so my co-authors were at a little bit of a loss for some of that. And you've all had an opportunity to receive the draft that we intend to replace that with, but maybe not enough time to review it. And so again, for those things, I apologize.